Okay, so now we're going to this pitcher with the valve. It's going to open up and it's going to allow these gases to mix together. And it wants to know, after these two mix together, what's the final pressure? So consider the variables that we talk about with gas laws and which one is going to influence the pressure. And these two are connected, and then they're not going to be able to change size. So also keep that in mind. So hopefully you are realizing that the final pressure is going to be found out if we know the total moles. All right? So moles, the more moles you have, the more pressure, the less pressure. Moles are going to collide with each other and exert a force on the container walls, which is pressure. So at the very end, are y'all okay saying, well, hopefully you're not there to answer me, moles of argon are going to be added to moles of helium. And so if we do these two, we know we're going to find total moles. Once we know total moles, can't we plug it into PV equals nRT? We'll know total moles are temperature. I'll show you how to worry about that even though it's not mentioned. Volume, pressure, and then we could solve for pressure. So let's think about this. What should we use to represent moles of argon? Because we don't have temperature right now, so we can't actually solve it and plug in a number. So looking at this, if I were to change this formula up to isolate moles, wouldn't moles equal PV over RT? So moles of argon equals PV over RT. Moles of helium equals PV over RT. If we know this and we know this, we can add them together, plug them into here. So looking at argon, I know pressure and I know volume. So let's replace this with 3 times 7 over RT. For helium, let's replace this with 1 times 5 over RT. Let's add these two together and then we'll have total moles. So I'm going to replace 3 times 7 with 21. 21 over RT plus 5 over RT, and our total moles are 26 over RT. Now that I know that, I'm going to plug that back in for moles into PV equals nRT, and we're going to solve for pressure. So I'm going to take this and stick them together. So I'm solving for pressure. I'm going to do it a little bit up here so I have a little more room. My volume is going to be total volume, so 5 plus 7. My moles is going to be 26 over RT. And then I'm multiplying that by RT. So what's going to happen here? These are going to cancel out. So pressure times 12 equals 26. 26 divided by 12 will give us our answer. Pressure will equal 2.17 atm. D. You'll see some other ones like this throughout the packet. Just make sure that if you're going to solve it this way, which is probably the easiest way, pressure's in ATM because your R has that unit tackled on behind it. ATM, liters, and Kelvin. So make sure those units are there. All right, let's go ahead and do the last one on the first page. All right, so at some place in the upper atmosphere, we have this many ozone molecules per liter, and we know the temperature. It wants to know the partial pressure of ozone in torr. So we'll just find it the normal way, and then we'll come back and worry about torr. Excuse me. All right, So I'm just going to lay out what we have. We know 5.0 times 10 to the 21 molecules of ozone per liter. We know temperature, 173 kelvins, and we want to know pressure. Well, since I have one of everything, I'm thinking ideal gas law. So really, ideal gas law comes in a lot. If I rearrange the ideal gas law, PV equals nRT, then pressure would equal nRT over V. So I know R, I know temperature. N over V stands for moles over volume. We'll have molecules over volume. So let's convert this to moles over volume, and then we have everything we need. All right, so molecules, I'm going to say Avogadro's number of molecules equals 1 mole. I forgot that that's over 1 liter. All right, and our units will be moles per liters. Now I'm going to plug everything into right here, and I'm going to solve for pressure. Okay, so that's not an answer choice, but that's because this is an ATM. The question asks for torr. And since I'm going ATM to torr, this is something that you don't need to memorize. He will give you conversion factors on your exam. So you'll go to the front page and you'll see that 760 torr equals 1 ATM. $89.63 torr. So A. Good deal. All right. Let's see what's coming up. All right, so I'm going to pause the video here. I'm going to come back and do 2 more problems on skill 3.